All right, welcome back, everyone. Our second speaker is Dr. Brian Whipker, who is a professor of floriculture at North Carolina State University. In the world of flowers, the goal of greenhouse growers is to nurture a gorgeous plant. As a specialist in diagnosing abiotic disorders, Dr. Whipker's goal is to seek out pretty dead plants and then to photograph them. For over 30 years, problem solving for growers has been his primary focus. Research projects have investigated nutritional disorders of over 50 species, optimizing fertilization practices, revising leaf tissue nutrient standards, and customizing plant growth. Ultimately, transforming these findings into diagnostic guides, magazine articles, and e-grow alerts is the goal and aids in the greenhouse industry in recognizing and preventing abiotic disorders. Brian, the floor is yours.
Thank you. So get the share screen up and going. See, there we go.
It is on.
It is on. Excellent. So I want to welcome everyone for this afternoon. The last speaker. It's a one of the best days of spring so far in North Carolina because we low humidity, nice and warm, but we got a little overcast, so it really made it easy to work in the greenhouse today. So I'm my own technician right now, so we're busy in the greenhouse growing things the spring season. So today, Bodie asked me to speak on plant growth regulators. So we do a lot of work here at NC State on PGRs, a lot of rate studies, a lot of the new formulations that have been developed in the US over the last 20 years. We've been doing a lot of the initial screening of a candidate formula. Is candidate or is formula 1, 2, or 3 the best? And then you pick it out, then you go through the process of getting recommended rates for that PGR. So that's been a lot of the work for the last few years. It's easy to grow a plant, and then we also then can put that in our yard if we want to, unless of course we overdose it. So we go to the higher end of the rate. So today I'm going to talk about plant growth regulators. The thing about it, PGRs are excellent tools to help manage growth, going anywhere from like helping on rooting with an IBA to trying to make the structure of the plant smaller, more branching, to try to control the growth. And there's even plant growth regulators that help enhance growth to make things tall. So there's a lot of tools in the US to make a toolbox to manage growth in a greenhouse and or outdoor setting. And so we're going to talk about some of these factors, some of these PGRs briefly at the beginning, but then go into some more specific applications. So what I'm going to talk about today are 4 main areas. I'm going to talk about the PGR resources that are available, and then go over some new applications. One is the Collate 2L Drench that actually just got EPA approval last week, looking at overdose ID and then holding strategies because we're towards the end of the production season in both Georgia and we're getting close in North Carolina. If you need to hold some of the plants because they're getting too big in case, for instance, the weather's bad. So let's start off with talking about new resources. So every 2 years, I do the annual Plant Growth Regulator Guide. It's a project with Fine Americas, and we do it through Grower Talks magazine. The alternate years, the perennial guide is now done by Dr. Garrett Owen. It had been with Dr. Joyce Latimer, who had been down at the UGA Griffin campus, then went up to Virginia Tech. But with her retirement, the perennial guide is now completed by Garrett Owen, who's up at The Ohio State University. So for the annual guide, it's 72 pages. It has new articles that we put on the front, use tables, and then we have some highlight articles that are towards the end. So for this current one, with the anticipation of EPA approval, which has taken 2 years to get through the process, we did update the use of Collate. Collate is an ethephon product like Florel, but it's a higher concentration. So the advantage of it, it's an excellent cost-effective PGR. and it's typically foliar applied, but now the drench application has been approved by EPA. In addition, if you're growing some succulents, sometimes with the slow growth that goes on, you might want to try to encourage a bigger plant so that it's fuller, that you cut down the window that it takes to get it ready for sales. And so to do this, we used a product that has both BA and GA, which enhances growth, called Fresco. And so we were able to enhance more growth on the plants. And you can see some of the photos here, and it's in the article that you can read in more detail. And then also we had an article on IBA for helping on rooting. Advocate is the product from Fine. The advantage is that it's a liquid, whereas most of the other products were either a powder or a dried material that you had to mix. So the ease of mixing helps on the process of applying the chemical. So there's an article in there. Plus then, of course, like I said, there's a listing of different PGRs. So if you're interested in seeing what might work for your operation, there's a section in there, plus the use tables. The other factor that with the introduction of Advocate that came 2 years ago, Garrett Owen headed up the development of the Advocate IBA guide. So it's basically a rooting guide for both annuals and perennials. And so in that, it has a number of tables and also some photos looking at optimal rates. So it can help you figure out where you need to dial in your rates for PGR. So both of these are downloadable guides that can come from the Find America's website. So find_americas.com. They're both under the grower resource aspect that you would have to go to grab and download those two guides. So they're free of charge if you're interested in doing that. If you're at like the Cultivate meeting, they'll also have these guides up there in the booth if you want to pick one up. So I want to shift now to the first area, and that is ethephon drenches. So this is a newly registered application, although the work on this has been done over the last 11 years. And so it just takes time to get some of these things to work and get it registered on as a product. So historically, we've been using it as a foliar spray. If you, Peter Kajoyan did a lot of work at University. Well, he's in Massachusetts. He had been at Ohio State. But the foliar sprays are used by many growers. And so, but now we're looking at substrate drenches, and we want to go over previous research, the label development, and the current research on that. So when you look at ethephon, Florel, Collate, it has applications in floriculture for flower abortion, bud abortion. So like the example here on this geranium, when you're trying to get that plant the size up, you want the energy to go in vegetative growth. You don't want the flower bud. So we can take that off. So we get rid of those flowers. And so, because a lot of times early on with the weather conditions, those older petals might lead to, for instance, a botrytis infestation going on. So without that, you get more growth. In addition, because of how it works, you stimulate branching, so you get a fuller plant. And because instead of one central leader, you have multiple, the plant is smaller. And so you get growth control going on as an added benefit. Now, ethephon works differently than the other PGRs like paclobutrazol. That's an anti-gibberellin synthesizer, so it keeps the plant small by controlling that. Ethephon works differently, but it's still very effective of controlling growth and giving the effects that you want in the greenhouse setting. So some factors to keep in mind when you're looking at PGR applications of ethephon, Florel, Collate. The sweet spot's about 250 to 500. And if you look at any of the magazines, the grower information that buys supplier, if they're going to give you a recommendation, it's going to be in that rate. If you go higher, you're going to get into trouble. You're going to have more effect. You might have some delay in flowering. So keep it in the sweet spot, 250 to 500 for that plant. if you're looking at applications, if you're going to do it for a vegetative propagation, you have to do it after the roots have formed because it will inhibit rooting if you apply it too early. The other factor is with getting more branching, you would think that the stock plant production facilities like in Central America would be using it. But the residual effect, if they put it on the stock plant and then take a cutting, ship it to you to root, you're going to have some stalling potential on rooting. So they can't do that. They can do it early when they're trying to form the structure of the plant, but later on, they have to stop doing that. And for finished plants, typically you apply it 1 to 2 weeks after transplant. And again, I'm talking here on foliar applications. And so you want to get the plant established. And part of the reason is you do not want to apply it to a stressed plant because it is an enhancer of that stress effect. And I'll have a slide on that, highlight that in a minute. So also on foliar sprays, there's the potential for flower delay. So ideally, no application 6 to 8 weeks prior to sales when you want it to flower, because it's easier to sell a flower with a flower or a plant with a flower than it is to sell one that's green. So here's a shot of an operation up in the mountains of North Carolina. And today would be a perfect day that this would fit in because people would come and want to buy plants. And so in March, and this is at the foothills. So he would go through and you can tell that the pink flower in one did not have ethephon applied, but the ones to the left did. And so he basically was trying to have some plants available that people would buy color if they were there, and then hold back flower development on the other ones. So he was staggering a little for flower development early on, but he didn't want to have to pick off blooms off those plants along the way. He would save labor costs that way. Now, as I said, with looking at the timing of that application to get that plant established, this is where the phytotoxicity comes in. So it's a stress agitator. So if the plants are stressed when you apply it, you're going to magnify that effect. And you can see here on this geranium, this is the effect in the case of overdose that occurred, but you can see rapid flower bud abortion. You can get epinasty on some plants, so a downward orientation. We saw that on marigolds that we were working with. You can see distorted leaves on some geraniums that you get it too high. Cupping, lower leaf yellowing, bleaching, and then you can stunt them. So don't over-apply and don't do it when the plant's not happy. But, those are the cautions, but it's still a very good and a very inexpensive method of controlling excess growth. That was the highlighting the use of ethephon for a spray. So let's look at the new application as far as it goes as a drench. And so it offers some advantages over a spray that you might want to consider for production. And so there is improved efficacy because you don't have missed spots on the plant and you have a reduction in the potential for phytotoxicity. So the work, as I said earlier, has been ongoing to look at this. And the first publication scientifically that highlighted this was the work that was instigated by Bill Miller at Cornell, along with some Purdue people, and then also some Michigan State people. And so they looked at controlling growth, and they did it on the 24 different species, plus some narcissus. You'd expect that because Bill Miller is a bulb guy, so he had to sneak that in. But the general recommendations are around 100 part per million. And if you start getting north of 200, you're going to start having some delay. The other interesting thing they found that when you apply the chemical, for the most part, you're going to have a release of the ethylene. Ethephon turns into ethylene by a release and controls the factors going on. So they measured that they can get over 120 hours of release. So that's where you get your PGR effect. The problem that comes in some areas of Georgia where you're over alkaline water, you need to make sure that the mixture is about 4.5. The reason being that if you start getting the pH up 6.5, especially 7, you hasten the release of that ethylene to the plant. And so therefore it cuts the efficacy. It doesn't have enough time to react to get the effects that you want. That's why if you don't control the alkalinity, you can end up not getting control one time versus another. And so there is a natural acidifier in it, but you need to make sure that, ideally a pure water source would be ideal to use for that. So the reference of that work, they published it in actually it was 12, I guess. I thought it was 2014. So now we're at 13 years since the publication of that effect. Also, then the work that was at Virginia Tech looked at some of the effects of ethylene drenches on herbaceous perennials. And so again, 100 part per million is the sweet spot. And they looked at whether or not the substrate, the soil, was elevated or acidic. And they found the effect that even if the soil pH was high, then it would release quicker and not be as effective. So basically it's the evolution of the ethephon to ethylene occurred, just like I said earlier on the case of a foliar spray. And so you need to control that pH to help on the effect. But again, 100 part per million seems to be around the sweet spot. And then finally, some other work that was done in 2016 was done at Iowa State. And they looked at basically rate and timing. So they did a number of rates, low rate, the 0, 50, 100, 200 part per million. And they did it day 5, 10, 15, and 20. And so what they basically found is if you apply it early and the plant's not established, you have more possibility of negative effects, too much growth control, stunted growth on that plant. And so you need the bottom line comes in, get the roots to the side of the pot and then make your application. And if you start getting past 2 weeks of growth when you're going to do that, which that's what's going to really actually happen, then you're going to start needing to move that rate probably from a 50 to 100 to potentially like 100 to 150. You need to up the rate slightly. The product's very inexpensive, so it's not really it's cost effective. So it's not really going to break the bank by using the slightly higher rate. It's a stress magnifier. So get the plant going, make sure the plant's happy, and that's what needs to happen for better growth control. So what's happened in the last year is that Vine was able to rework their supply chain on Collate. And so they spent some funds looking at Cornell, Iowa State, Michigan State, NC State, Virginia Tech, and Ohio State of looking at refining those rates. And they basically just to check out what's going on there to make sure it works. And things were basically confirmed from the prior work that was done in those northern tier states of New York, Michigan, and Indiana. So there's been a number of trials that have done. So there's a new label that's out there. So it has the trial rates, the mixing, the volumes, and make sure the plant's well established and don't apply it to stress plants. So there are some cautions. So it is an acid. You don't want to get it on you. There is an eye warning, and because of that being acidic and the eye warning, probably the major disadvantage of it is the REI in 48 hours. And so that is probably the only downside to this product. So the EPA approved it just last week. So we've been waiting on this. And so you can use current stock of Collate by just downloading the new label. And you can get that if you go to their website, go to U.S. products, ornamentals, Collate, and click on the label. The label that's listed there, if you look towards like page 6, is where the drench part has been added. It might be page 8, but anyway, that's what you need to be able to start using even your current stock. You don't have to buy something new. So it has some potential for what you might be looking for growth control. The advantage is it doesn't have as much long residual and it grows out of it. So if you're doing plants for the landscape, you can get the growth control in the greenhouse, but then your end producer or buyer, the landscaper, the homeowner, doesn't have the effect. So here's some trials that we did on seed annuals. We applied at this stage development of these different plants. And so the roots were at the side of the pot. Now, we like to kill plants, but we also need to see how high can you go to see, so you know what happens when you go too high. That's the old uniroyal way they used to do it with bonsai. So that's kind of how I learned. So the sweet spot is the green ones, 50, 100, 200 part per million. Yellow starts getting high. It's getting hotter at 600 and 800. It's pretty red hot. So I'm not saying to use that. We had to do it to see the effects that were going on and see what happens when you go too high. So here's an example, pansies. So at 50 part per million, 100, we got good growth control. And so you still have flower buds that are on there. So you don't have the same studding that you might experience with uniconazole or paclobutrazole. There we go. Sorry, I hit one too fast. Here's salvia. So another good example, 50 to 100, it's going to be your sweet spot. If you start looking at 800, you start running into problems. And you can see here earlier that we had delay of flowering, we had stunted growth. So definitely that rate's too high. You got to be at the lower end, but we know what happens if you go too high. We did a number of things, trials on Coleus. Now this one's Coleus or Collate foliar spray. So you can see I really like Collate or ethephon because you can use either product on Coleus. You might have a little change in coloration on some of the plants, but you control growth without stunning it because there's such a wide variety difference on response. You don't know if it's too little, too much, or just right. So this offers the ability to better manage that. So here's the effects, the foliar spray. Here's the effects of the substrate drench. So you can see it's very effective. We went up to 1,000. That's too high, but 125, even going 175 probably are going to be very suitable. If you're in South Georgia, go a little higher on the rate. If you're closer to the mountains, you can cut back on the rate. You're not very different than we are when you're looking at things in North Carolina as far as trying to dial in rates by location. So we also did some work on petunias with my grad student, Patrick Veazey, 3 varieties. And you can see here that we had the growth control, but you can also see the effect that if you start getting too high, what happened? You did delay flowering going on. So 50 to 100 parts per million controlled some of the growth on there. Here's a second variety, the same thing going on. And then you start seeing that it's less reactive on flowering. You have flowers that are 200 part per million, but the plant is quite a bit stalled or smaller in size. And then another thing that we did, this goes back to some work probably 10 years ago that we did this. Plumbago, I love that plant, but it's a weedy thing. It looks great in the landscape. The problem is if you apply a Paclo or a uniconazole or a top floor type of product, you can, again, the sweet spot of being not enough, too much can happen. But it really turned out that ethephon gave you the branching, look at that plant, the branching in smaller size. And so it's a nicer plant compared to the one that has the untreated control that's there on the left. Here, just a little closer highlight of those 2 rates. Now, the one thing that you do get, piccolos, paclobutrazole, top floors, fluoroprimidol, these 2 are anti-GAs, and it's a little difficult to see in the photo, but you did get the standard and a little more intensifying of the blue color that went on. But you can see that you have a chance of stunning the plant and how quickly is it going to grow out. So that's where the advantage of ethephon would give you growth control, a fuller plant for production. So it works well for controlling growth and giving you robust plants. Make sure when you're using it, get the roots to the side of the pot before applying it. You're going to lead to some troubles. And if you have, what you're going to do is you're going to knock the plants up off of being even. And then later on, your unevenness is going to also start affecting your irrigation strategy. So you're just creating problems for yourself. So get the roots to the side of the pot so they're happy. So if you're going slightly earlier, think about 50 to 100 part per million. And then if slightly later applications, 100 to, you might want to go 150 before you get comfortable at 200. So it works, it's cost effective, it's something to consider in your PGR toolbox. So now I want to shift gears slightly, with us being a little more on the diagnostic side, that looking at trying to ID PGR overdoses, and then what do you do if you do have an overdose? So if you get the plant growth regulator works very well, but a little works great and a little too much, not so much. And so you get that stunted growth, the small internodes occurring. Many times you'll have delayed flowering. So that's not what you're gearing towards for what you want in production. But boy, those plants are really green. They just stay green for a while and don't bloom. So when you look at trying to diagnose disordered growth, there's a lot of different factors that you need to look at, both abiotic and biotic. And so with distorted growth in a plant, the big ones are the top row. Calcium deficiency, especially boron deficiency, like on pansies, broad mites, herbicide damage, and I have to move things around here. There we go. The photos were in the way of the participants, so I couldn't. And then thrips is another common one. And then second tier are all secondary minor problems, including plant growth regulators. So some of those are out there that you're going to end up, or you can run into for trying to diagnose a problem. So knowing what went on helps you figure it out, because a lot of times it's like, it's the PGR that did it. Well, it might not necessarily be the case that occurs with the plant. So I want to talk about the ones in the box, the red circles. So when you look at PGR overdose, basically the plant's going to be stunned and distorted. You're probably going to have a delay of flowering, or flowering's going to be aborted. So the easiest way then to look at it is to see whether or not you had an application that could have caused that. You're going to see if you overdosed it, you're going to start seeing the initial effects about 5 days afterwards on the higher active material. You look at the growing tip, you can see that the internodes are shorter, the plants are darker green. So you kind of have an idea. If it's plugs that you're getting in, the whole tray is going to be like pretty darn stunted. So you know that from the get-go, the plug supplier overdosed it on you, and that can be a challenge sometimes. So here's some plants that was in the landscape. They were in pots in front of a business, but you can see that the grower nailed the holy Toledo out of them because the growing tip is small. No, it's magnified because it's over the winter time and you're not getting growth. But I'd start wondering whether or not it was something else other than PGRs, like a broad mite infestation on the plant, that it's so badly stunted. And so the other ones that then are more likely to happen, boron deficiency. So the key here, here's the New Guinea Impatiens. If you grab that plant and you touch it, it's brittle. That leaf would crackle. I mean, it did, because we played around with it, and you could break it apart, and you lose the growing tip, and you usually then get axillary shoot development coming on the plant. And so you can get it from putting the plant too deep. You can get it too much water in propagation, loss of the growing tip. Pansies are notorious for it, especially fall pansies. It's difficult to take a tissue sample and get it diagnosed because it's gnarly. It's a dry weight basis. There's still boron there in that smaller area of the plant. So it's a little a little tougher to get the diagnosis going. Broad mites can happen. We've seen a lot on New Guineas, but you see a clear zone of good leaves and then gnarly leaves. You need to look under the microscope so you can see the adult female here. And then these eggs, the oval eggs with the white pockings on it, is really the classic diagnostic case that you look at. But you need a 100x microscope to look under there. So you probably are going to have to send it to a diagnostic lab. You can't see it with your naked eye on that plant. And then the growth is gnarly. And so we've been having problems with New Guinea impatiens is probably the biggest one it's been popping up. I haven't seen any this year. There's been prior years, but there was an egro alert a little earlier that suggested people were seeing it in some operations. Herbicide drift like 2,4-D, you see the distorted growth going on. Drift can come miles. And so just because you didn't apply it doesn't mean your neighbor didn't. It comes through if it comes through the greenhouse vent, usually if it's a low dose, it's more severe where the air intake is than further down. But if it's a high dose or you applied it outside the greenhouse so it could get a good whiff, it can go down the entire greenhouse. So you just have to know what you applied and what is affected. Tomatoes are notorious for showing it. Grapes are too. Some of these herbicide problems can be a mile that we see it. And don't put if the herbicide's not registered for a greenhouse use, there's a reason for that. It vaporizes and then it's going to kill everything. Even if you apply it in the summer, when you put the plants in and you start watering it, it will vaporize then and do a great number on the plants. And we see that. And then I have IGRs, insect growth regulators. This was our research project. We could not figure out what went on. And it was an IGR that got applied in Lobularia did not like it at all. It just melted it down. In the first case, it was quick. The second case, the first case, it was slow. The second case, it was quick. So it was really hard to figure out what was going on when you don't see symptoms for 2 to 3 weeks after application. And so if it's really severe, you can trim it back, but economically, it might not make it for you. And here's some other chemical phytotoxicity. So here's judo, like I said, on Lobularia. Here's the distortion with kudos, and then ethephon that we talked about. If you overdose it, you can get the leaves that way. And then the classic distance, you get the puckering of those leaves, and that's an insecticide. So how you overcome plant stall. So there's a lot of different reasons for that. If your rate of fertilization is not high enough, the temperatures are down, cloudy, PGR applications. So how do you stimulate new growth? The answer to that is either Fresco or Fascination, which is a combination of 6-BA and GA. Foliar sprays for both, but only drenches and chemigation are on the Fresco label. So if you're going to use it, a 1 to 5 part per million rate, the sweet spot I tell people is try 3. Make 1 application. And if the plant growth hasn't started, you can come back again, look at it for 7 days, but usually use half a rate the next time. You're trying to see how far you don't want to slam on the gas. You want to tap on the gas to get it going with that plant growth. And so you're trying to overcome the anti-GA effect. And so again, 1 to 5 is the rate to work on. 3 would be better. Do not go over 10. You won't be happy. You'll get the growth. And then you get to apply an anti-GA PGR to stop the growth. The chemical companies are happy to sell you that product, but don't do it. Here's a case of just looking at an application just to stimulate a little growth. If the plants are stalling slightly, they might make an application. So here's the case of a begonia starting to grow, trying to get a little more growth on pansies, and there's the rate. Here's the case that we nailed these New Guineas with a pack-load drench at 8 part per million. That's a good sized nail. And so you can see how they're tight, the buds are not there. And then we did a foliar spray, 2.5, 5, and 10 part per million. And you can see, number one, the flowers are there. So if you got flowers, you got sales. This one, not so much. And so if you want more growth, that might not be what you want because you need to hold them and keep them tightly spaced. So, again, 2.5, 5 part per million, that's your sweet spot to look at for overcoming that problem. If you get it too high, you can, and this may apply too much here, you can see what happens on the stretch. And you can see it close up here because I took that plant home and bloomed it out. So spindly growth that occur. You can see here that we did excessive rates. This was 10 part per million. You get the slightly discolored leaf color. It greened back up a little later, but it stretched and it was not quite as great. Here's a case that thing spilled. So it's 100x rate. So you can see it works. It worked a little too well, but that's not that, all the other plants were fine. But the case is trying to get the extra growth on the poinsettias to make them to spec is what they want. Excess rates, you're going to get too much growth. You can always then make another application if you need to do that. Also keep in mind on poinsettias, drenches are probably a little better. We've seen some phyto and foliar sprays. If you over apply it though, you can get some bleaching or greening going on. So test some crop. And you can see here, the grower was pretty loose of making multiple applications. So you can see that the bracts, instead of pinkish, are green, the same thing here. And so you're not going to get the same bract coloration going on with the plant. So the product works. Make sure that, especially if it's a terminal plant like a mom, a poinsettia, you got to apply it so there's enough growth potential for it to go ahead and grow to get the effects of sizing up that plant. And there's an article in that PGR guide that covers using Fresco for enhancing growth if you want more details. And so briefly on the next few minutes to finish up, I want to talk about control strategies. We did an eGrow Alert 9.2. We did this right when things hit the fan with COVID because we were, like you guys in Georgia, we were in shipping season and we were in trouble. So how do you hold them back? There's a lot of different strategies to hold plants back. Lower nitrogen rate, lower phosphorus, negative diff. They like this. You're not going to get a lot of negative diff. You're going to get positive diff. So you're going to get the stretch going on. So you're in the same boat in Georgia as we are. We're not Michigan where it's 35 out there and you can just open up the vent. A hard pinch, but that delays you, and then open your PGR toolbox. So just some illustrations of some work we did. If you do lower rates, you can see 75 part per million. The plant's still full, but it's a little smaller. So you just notch it down a little. That's what the big operations are doing to tighten the spacing. The plant still looks good, just controlling some of that growth that goes on. Here's some work that Josh Henry did during his master's looking at lowering phosphorus. For most plants, we do not need more than about 10, or if it's a fruiting species, 15 part per million phosphorus. If you use 20-10-20 at 200 part per million, you're giving 44 or 42 part per million phosphorus, more than you even need. The plant, you don't get any additional benefit. It flatlines on you. Now, as you can see on the zero, deficiency does occur. Phosphorus is a essential element, so you need it. But somewhere, if you were going to limit things to try to control growth, that's 5 part per million, 7.5 part per million seems to be the sweet spot without getting stunted growth. The other thing that you could do is you get the plant up the size and then cut back the phosphorus is very effective. But you're gonna see deficiencies in 2 to 3 weeks. So you just cut it back and then do a periodic application to avoid a phosphorus deficiency from coming in. So also, PGRs, low dose drenches of 0.1 part per million, based on some of the work that Jim Barrett did down at University of Florida. You can see here, now this is part per billion on that number. We were looking at contamination. So you can see even low dose drenches will control growth. Now, of course, a begonia is very sensitive to taclo, so you expect that. But you can see the concept here of what possibly work. Here we did some drenches once and twice at 2 part per million, the upper row, 4 part per million, the bottom row, that kind of tighten up those hanging baskets. And you can see that, it's a sweeter looking plant here compared to the more open foliage based one that's there on the left. So it's a nice application to control some of that stretch. And then you can get more plants on a cart for shipping. And it cuts down water use. So on the consumer end of things, it's a better product for them also. So it's a win-win across the board for this application. So CPRO had a cocktail that was out there also for annuals, doing some A-rest plus some B9 and a slightly higher for perennials. And this is for the retail, that if you're having to hold plants, like you're getting some rainy weekends and you can't get them sold, it works pretty darn well. So those strategies are in that eGrow alert. So egrow.org, number 9.20. So fertilizer, just cutting it down works fine. So do want to thank the research sponsors, because can't get anything done without help. So we do a lot of work with Fine. We do a lot of work with SunGrow. Plant material from Ball, Syngenta, and Doom Orange has been very beneficial to our program. So we appreciate that support. So with that, I am 2 minutes early. So I did make it through the slides. So there's Bodie coming back. And so we did, the year after COVID, we did a Coleus cultivar trial, because we had to throw everything out the greenhouse the year before. And I said, if it's going to happen, we're just going to do something fun. So we grew 114 cultivars of Coleus. So then this was my little artistic effect of getting the leaves together to make my image. So with that, I will stop sharing so I can see also the questions and turn it over to you, to Bodie, if there's any. I don't see anything in the chat. So any questions people might have?
Brian, that was great. It reminded me of my time in the greenhouse many years ago, and what a fine-tuned ballet it is between the plant, the grower, the environment outside, the environment in the greenhouse, the people that work and deliver those chemicals to the plants. That is just you don't have much, if any, error. I mean, it's a tight window for everything.
It's a tool. It helps. Now with Fresco, you can over apply and then stimulate, and then you can come back again. So it's, as long as you got flowers and it looks good and you didn't burn it, you have a lot of options. So it just helps you fine tune what's going on, and it makes the plant look better. And they're in the PGR guide, there's also an article about the advantages, water use and other things that you might want to look at. So it's a free download. And so I just love, it's a nice product to write, because I love how they got great designers at Grower Talks. And I say, one year we had the plant material there, and I said, man, this is plant porn. Look at this centerfold of these plants here. So I always I thought I was a good designer, but then I see what the professionals actually do at the magazines, and I'm in elementary school compared to them. They got a PhD in that. So there's some good resources there if you're looking to start using PGRs, and it explains some of the things. Where would you start? Most people do it diminizide. And so, and I'll keep on I'll go down this line of talking, but I don't see any chat question. So diminizide is low cost, easy to use. If you need something higher, it's a paclobutrazole, like Piccolo, like Bonsai would be the ones to be looking at. And so start on a small scale, do some applications. I mean, you for the most part, by being able to tighten things up, your increased efficiency is about 100x return on investment compared to the price of the chemical. So it's an investment to grow better plants, and they're healthier, they're disease resistant, they establish better in the landscape. And that, assuming you got the rate, you have to overdose it. I gave some to the local chemical guy. guy, and he said those scabola never grew. Actually, in fact, they died because they never got the roots out into the soil.
Right.
And then
Yeah.
they dried out with that dry period. So you can do too much. A little loving is good. Too much loving's bad. So any questions? I don't see any popping up. So we can always quit early. They paid the
I
same.
have a question. So you ended up with your collage, which was beautiful, by the way. I really appreciate you adding this visual at the end. So what did you learn as far as Coleus and the 100+ cultivars that you grew? Did you apply? I'm thinking you probably must have done some PGRing on them.
We did a number of side studies. We looked at phosphorus rates, again, 10 part per million. That one was published. We looked at pH values, so it reinforced the sweet spot's 5.862. It can be up to 6.4. It's not susceptible it will get iron chlorosis at 7 and above, and it does not get. It's not an iron manganese accumulator. So if the pH goes low, you're probably going to stunt growth, not see the visual symptoms of iron manganese toxicity. The other thing we did is we collected the tissue. And so we tried to see whether or not there was a color difference in nutrient levels. And while there were some trends, there was bigger differences amongst the cultivars within a color group than amongst the color groups. So you just have to go generic. Those are the big factor. And plus, they really look good in my yard. So I love it. Now, I like Coleus. The grad student, he was an undergrad. He still hates them from that study. I don't know. Oh, we did a little trees also. So that was cool. But I'd done them as a grad student, big ones, but they're too brittle stems. So mini ones we saw at Longwood Gardens one year is a nice little sweet spot if you want to try something different. So
yeah, I agree with you. Coleus is spectacular. I really, really enjoy seeing the wide variety of different patterns and colors and shapes and how vigorous the plants look, and some that are ferny looking like the one you showed. And yeah, it's a really great plant.
Yeah, most of the cultivars that are out there, the Duman, the Syngenta finally came in, the Ball, they're all out of University of Florida research program.
Yep.
They really
Big
did a
plugs.
nice job. And so introduced those, some resistance to downy mildew. That was the problem back in about 2006. So there's some nice new colors in different forms. There's still some of the old ones that are out there. I was looking at some of the old literature back from about 1900. And there used to be a burgundy one that got 7 feet tall. So it probably was a weedy looking thing that you can't find it anymore, but it would have been something to look at. So yes, Coleus are interesting. So
it must have looked like some kind of tobacco or something. You can
yes,
only imagine.
yes, a burgundy tobacco. So yes.
Yeah.
So all right.
Well, we're not getting any questions. I'm sure that everyone really learned a lot, and thank you for sharing your expertise and the many years of research that you've spent in accruing this information and sharing with us the latest in technologies as well as labeling. Thank you again, Brian and Ruchika, and happy growing and happy spring.
All right. Thank you. All right. Ciao.
Ciao, ciao.
All right, folks. That's it for the month of March.